In this particular session, we'll be discussing about automatic support creation through code, and this typically helps you in creating different type of support by keeping degree of freedom in mind and assigning those typical supports to the base or the foundation point where you want to assign those supports. So for understanding this, let me open our exercise file so that you can better relate that. So open this particular file, and you can see here one particular node is fixed here, and if you go to the code, you can directly see supports 115, which you can see here. So just I'll go to the levels, node number. So to this 115, you can see there is a fixed support. Let us say to 116, I am interested to go for pinned, and maybe to 126 I need a fixed spot, and where I have this degree of freedom arrested. So only I have fx and fy, all the moments and the z direction freedom is arrested. And for my 105, I need to arrest fx also, and only the y direction is free so that it can move like that. And to another member 106, I am interested to go for the fixed spot, and where I need to have a moment, and fx and fy, fz, mx and my moment all are freezed. So what about my other point 121? Here you can see there is a 121 point for this. So 121 will be a fixed, and go to file and go to save, and you can exit this. And now you can see that typically at those points, those type of joints, that is your support has been defined. Here also you can see the description, according to that all are defined. So typically if you want to try a particular load, maybe this I don't want to apply at 105, I will just delete this 105. Maybe we'll be trying some other code. Just I will exit it. I'll go to code. I'll just delete this. I'll save this. So typically you can find what is the code for a particular type. You can maybe interested for the foundation, where I'm looking at a particular length 2 meter by 1 meter, and you can give a particular modulus for that. So what is the kilonewton per meter square per meter, in which direction? I am looking at y direction. Add. So what the code that will be generated, that you can see. So these are the different supports which you can see. You can edit this, and you can see this all the information, and when you are interested to apply at a particular point, and directly you can record the corresponding codes, because everything you don't have any particular method to find. So elastic footing 2 1, this basically specifies the size of the typical footing, the direct y, the direction, and subgrade 30 is the particular bearing capacity which you can specify. So this is the code which you can keep in mind, and you can apply this for other also. For example, I'm not interested for this 115, So 115 I'll be deleting, and this particular code I'll be using for 115, and this specification for this will be 1.5, and this is 1.5 square, and direction is Y, and subgrade is 30, and I will save this, and I will go for exit. And now you can see here also you have the specification which is ready to 1.5 this, and this automatically when you change, if you go to change and you go for the code, no need to worry, that is replicated and instantly embodied. And this is what, so this all the code you can experiment one by one. So what is the code which is generated? So after some time you will automatically come to know, okay, I am interested to define this fixed bot, or maybe you go for inclined, what the data I need to input for getting this is the release. If you go to the typical one which I discussed, fixed bot, here when you select the MX, MY or FX, FY or FG, then you can see the particular stiffness in that direction, which also you can specify in this particular box. When you release this, you cannot specify. So like this, you can typically control this also. Let us say I'll be applying to 10 to this particular point. This is free, and I'm looking at a particular stiffness for this X direction, and this is only free. And when you go for add, you can see this is the particular typical notation, and I'm adding to this particular node. Select crusher node, I'm selecting to this node, assign yes, that will be updated, and go to code for 115, and you can find the 115 will be fixed part. This, the K is the stiffness, KFX is this much, because in the X direction I am specifying the stiffness is only having this much degree of freedom with this stiffness. It is not completely free. So if you want to restrict the degree of freedom to certain extent, the initial strain or the displacement you can allow to certain extent by using this particular mechanism which I have demonstrated and explained you in this project, and you can take the advantage and use for any critical project.